Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides additional practice using StatCrunch to find probabilities for the standard normal distribution. Let's get started. So, as I mentioned in the previous mini lecture, your Z-score tables are found entirely within the normal calculator in StatCrunch. And this is very useful, certainly in my opinion, much more useful than the Z-score tables. And when I took stats in college, I had to use the Z-score tables, and let me tell you, they're a whole lot better than actually going through the integral calculus that I would have to employ to calculate the probability underneath that density curve for the standard normal distribution. But now that we're in the 21st century and we have StatCrunch, yeah, StatCrunch is like a level above the Z-score tables in my opinion, because it's so easy to get what you want. You don't have to look at a table and find your column and heading values. You don't have to worry about any interpolation. You don't have to worry about adding the two parts of your Z-score together. You just put in the numbers you got, and out comes the number you need. So I really recommend using StatCrunch, although if you want to use the Z-score tables, they are there for you. But my preference is for using StatCrunch. So let's look at some examples which we can practice calculating the probability for the area that's in a given shaded region for the standard normal distribution. So here we have a Z-score of 0.47, and we're asked to shade the area to the left. So how is it that we do this using StatCrunch? Well, let me walk you through that step by step so that you know how to do this. Check this out. Okay, we're back in StatCrunch. I'm going to show you right now how to calculate area under the curve given a Z-score. Now, because you're given a Z-score, you know that you're talking about the standard normal distribution because that's what produces Z-scores. Z-scores come from the standard normal distribution. So to start, I'm going to come up here and go to Stat, Calculators, Normal. It gives me my normal calculator. And now, notice we have the mean of 0, standard deviation of 1. So this is the standard normal distribution. That's the default here in the normal calculator. And the Z-score is going to go right here where the random variable or the horizontal value normally appears. So I put my Z-score in here, so 0.47. And then we want the area to the left. So I need to make sure this inequality sign is pointing to the left. So we have that. So all I do is hit compute, and there's my answer, 68.1%. That's really all there is to it. Hope that helps you. Okay, so back here to our problem. We're asked to find the area that's shaded to the left of a Z-score 0.47. And so those are the values that we saw. We're putting into our calculator there in StatCrunch. And notice that the Z-score is the number here in the left field. The area is the number here in the right field. So this is the area that we're looking for, 0.68. The other reason why I like using StatCrunch is because it's got that visual representation there as well as this calculation. So you have sort of a visual check to see, yes, we really are calculating the area to the left, which is what I've been asked to do. Find that area that's there on the left. So it's a good visual check for you to make sure you're calculating the right number out. Let's look at another example here. Z equals 1.92. We're asked to get the area to the left of that Z-score. So I've shown you how to do it. So go ahead, stop the video here and get into StatCrunch, get that normal calculator going, and see if you can find the area to the left of Z-score of 1.92. Okay, I hope you got 0.973. This is the number that comes out. This is the area that's to the left of that Z-score of 1.92. So if you didn't, then check your numbers against the numbers you see here to make sure that you got everything right. What about a Z-score to the left of negative 2.9? You can see it's just a really tiny little blip right here on the left. So a really small area. We're not expecting a big number. but we are expecting to get a number. So what is that number? Go ahead, stop the video, get into StatCrunch, see if you can find this. Okay, let's see how you did. So you should get a really small number, about 0.2%. That's what we're looking at here. So if you didn't get this number, again, check to make sure that your settings in your calculator are what you see here on the screen. What about the area to the right of negative 1.65? Stop the video, see if you can find this in StatCrunch, and come back and we'll see how well you did. Okay, let's see what you did. So hopefully you got 95%. That's the area that's to the right. And notice that if you didn't get this, probably what you missed was this inequality sign here. The default is less than, but you want to make sure that, this is like an arrow pointing in the direction for the side that's shaded. So we're shading to the right, so you want to make sure you've got the greater than inequality sign because that forms an arrow pointing to the right. That's the side we want shaded. So if you missed this one, that's probably where you missed it. So make sure you pay attention to that when you're working these types of problems. So make sure that inequality sign matches the proper side you want to shade. What about the area to the right of our z-score of 1? Go ahead and calculate that, and we'll come back and then see how well you did. Okay, hopefully you got 15.9%. That's what we calculate here. So if you didn't get that, make sure your numbers, your inequality sign matches so you can get the right number to come out. What about a z-score that's greater than the area that's greater than the z-score of 2.9? Well, I hope you got this really small number right here, 0.00186581, really small number, because we can see there's a really small blip here that we're looking at, and that's our area under the curve. Now notice something interesting here with these two z-scores you see on the bottom of each of these columns here. So the z-score for the one is positive, the other is negative. They have the same absolute value. And notice that z-scores with the same absolute value, that the tails that correspond with those z-values produce the same area under the curve. That's because, as we've seen before, the standard normal distribution is symmetric about the mean. So this is a useful property to keep in mind. Sometimes it can help you to get the number you need quicker than actually running it through a z-score table or even a calculator inside StatCrunch. Let's do bone density test results. Let's work some more problems with this. So if we want to find the probability that a randomly selected patient will have a result less than 0.29, we can do that in StatCrunch. So go into StatCrunch, see if you can calculate that, and then come back and we'll see how well you did. Okay, let's see how well you did with that. So you should be getting 61.4%, 0.614. So that's the z-score right here, 0.29. We want less than that, so we want the area to the left. So that's our inequality sign pointing to the left. That gives us our 0.614 probability. So the area of the curve is the same as the probability. How about greater than negative 1.26? Well, here's the answer there. Make sure your numbers match if you don't see the same answer coming out. Greater than 2.87? Again, here's what you should get. Make sure your numbers match if you didn't get that. Between 0.15 and 1.11. Yep, here's what you get there. Make sure you use that between option, and then you can put in the two values that you're given to calculate between. Between negative 1.11 and negative 0.15. There's the values there. Less than 1.96. And you should get 97.5%. So if you didn't get these, make sure you check your numbers, your inequality signs, to make sure everything's kosher. You need to know how to do these to solve problems in StatCrunch. And that brings us to the end of this mini lecture. I hope you found it helpful. Thanks for watching. We'll see you in the next video.